We are going to practice problems using sum and different formulas for cosine and sine. Look here, I wrote down formulas for sum and difference. So when it's come to cosine, first two formulas is a sum and then difference of cosine. What is interesting about cosine, sum and difference, when you have sum here also you are using the opposite sign. Okay, when you have cosine here is difference, then you are using here sum, so you flip the sign for the cosine formula. The other thing is interesting, cosine stick strictly to cosine stick with cosine, sine stick with sine. This is about cosine thing. I'm helping you to remember easy. So the opposite way is sine. When it comes to sine, sine is using mixture with cosine. Look at that. Sine alpha, cosine beta, cosine alpha, sine beta. So first time you use sine alpha, cosine beta, and then second time you use cosine alpha, sine beta. The same thing here. Look, you have same terms for difference. Cosine alpha, cosine beta, just like here. And cosine alpha, sine beta, just like here. Okay, with the difference, that addition here will give you also addition, subtraction here will give you subtraction. Okay, so one more time. As you can see, let me see, cosine alpha, cosine beta, here also cosine alpha, cosine beta, sine alpha, sine beta, here also cosine alpha, sine beta, right? And the sign, you flip it. If it's plus here, you put minus. If it's minus here, you put plus. Okay, let me go back this mess I created. Okay, next. One second, let me clean all this mess. There we go. Now the same thing, it's happening with sine alpha plus beta, sine alpha minus beta. So you have the same way, sine alpha, cosine beta, and cosine alpha, sine beta, in both cases. And when it comes to sine, so if you have plus, here also plus, unlike with cosine, you have minus, here is minus. Well, I don't know if this will help you to remember, but at least I tried. At least I remember that way. It makes me easy. So cosine is more strict, more demanding. Cosine stick with cosine, and then sine stick with sine here. But the sine formulas is more lenient, so it's like sine with cosine, cosine, it's more friendly. Okay, all right, so let's start working. So first problem, we are going to verify that sine alpha minus beta over cosine alpha sine beta is gonna be equal to tangent alpha, tangent beta, and minus 1. Okay, this is too thick. All right, better. So let's try. So sine alpha minus sine beta, we are going to use formula number 4. Okay, so let's open it up. We are going to get sine alpha cosine beta minus cosine alpha sine beta. over cosine alpha sine beta. All right, let's solve it. So what I'm going to do, since we have common denominator, cosine alpha sine beta, I'm going to divide every single term by cosine alpha sine beta, which is going to be sine alpha cosine beta over cosine alpha sine beta minus cosine alpha sine beta over cosine alpha sine beta. So let's see what we can cancel here. Can we cancel anything here? Cosine alpha sine beta, cosine alpha sine beta. These both I can cancel with this one. In this here I cannot cancel with the first term. But what I can do, I can combine these two the way that sine over cosine is a tangent, right? Sine alpha over cosine alpha, it's tangent alpha. And cosine beta over sine beta is cotangent beta. Actually, I'm very sorry, this is supposed to be cotangent. Okay, so cotangent beta and minus here will be 1, which we had to prove, and we got it. Okay, next one, number 2. Problem number 2. What we have here? We have cosine alpha minus beta over cosine alpha sine beta. Okay, so cosine alpha minus beta, I'm going to apply formula 2. Apply formula 2. Let me bring it down. As I go down, I'm going to bring this down so we don't have to stroll forth and back. Okay, so we have it here. So let's solve it. This is gonna be cosine alpha cosine beta plus sine alpha sine beta divided by cosine alpha and sine beta. This is going to be equal cosine alpha cosine beta over cosine alpha cosine beta. Okay, and plus sine alpha sine beta over cosine alpha sine beta. All right, so what we are getting here, sine cosine alpha here, this is gone. Sine beta over sine beta, this is gone. And as a result, we are getting cosine beta, sine beta. So cosine beta over sine beta, we are going to get cotangent beta, and then plus we are going to get tangent beta, right? Because sine alpha, tangent alpha, sine alpha over cosine alpha, we get tangent alpha. And that's it. We are done. Next one, it's going to be number 3, cosine x minus pi over 4. Okay, so x minus pi over 4, that's going to be formula 2, right? Alpha minus beta. So what do we get? Cosine x, cosine pi over 4 plus sine x, sine pi over 4. Okay, so, and this is going to be equal cosine pi over 4, it's 45 degrees. Remember when I said cosine pi, let me write down on the side, cosine pi over 4 is equal sine pi over 4, and it's equal square root 2 over 2, which means we are getting square root 2 over 2 cosine x plus square root 2 over 2 sine x. And if I take square root 2 over 2 as a common factor, whoever need to refresh memory about common factor, look in the same playlist, because I have there recording common factor. Okay, then we get cosine x plus sine x. Here we already simplified. All right, number 4, cosine x minus 5 pi over 4. Okay, what do we get? So since this is cosine alpha minus beta, right? It's right here. Bring more down. Okay. So it's going to be formula 2. And when we apply, we are going to get here cosine x and cosine 5 pi over 4 plus sine x and sine 5 pi over 4. That's a formula 2. Okay, well, let's see what we can do. 5 pi over 4, let's figure it out how much it's going to be. So I'm going to do some drafting here. 5 pi over 4, so it's going to be 5 times, oops, let me see, yeah, 5 pi over 4 is equal 5 times 180, right, over 4. This is gone, this is 45 degree, we get 225 degree, correct? Okay, let's see how much is 225. 225, if this is 180, right, this is 270, so 225 will be somewhere here, right? 200, will be 225, correct? Well, this terminal side is a side for 225, and this piece is going to be how much? 270 minus 225. It's going to be 45, so this is going to be 45 degrees. But this is going to be with negative sign, yes? With negative 45 degrees, this piece. Or it's going to be, this piece is negative 45, and plus 90 will be 135, right? Negative 135 degrees. But for us, it's going to be practically this piece, the piece is going to be 45 degrees. Okay, so we are going to get, cosine, we have cosine here, cosine 5 pi over 4. In this third quadrant, we have cosine negative here, and we have also sine negative. So both of them are going to be negative square root 2 over 2, right? Why? Because 225, if I do minus 180, I will get 45 degrees. So this will be 45, right? And this one also 45. So we get square root 2 over 2. And result is cosine x, here square root 2 over 2, plus square root 2 over 2 sine x. Okay, so I keep looking at this picture. The other way, it could be easy for you if you would imagine this way. Let me do it. So this is 225, right? And we said this is going to be our 225, 180. So that means the angle up to here is 180, right? So how much will be this piece? 225 minus 180 degrees. It's going to be 45 degrees, correct? So if this piece is 45, that means this piece also 45, correct? Or this piece is 45. So, but because it's in the third quadrant, and cosine is negative and sine is negative. Therefore, we are going to have both of them negative. All right. And here is also, let me put it negative. So what do we get here? We are going to get negative square root 2 over 2. I take out, and in parentheses I will have cosine x plus sine x. Okay? Okie dokie. Question number 5. We are going to solve another one. Sine 45 degrees minus 30 degrees. Here is the thing. You can do 45 degrees minus 30 degrees and get sine 15 degrees. But we don't know. The unit circle table doesn't give us 15 degrees unless we can, all we have to do punch on calculator, right? Sine 15 degrees. But if a calculator is not around, what you're gonna do, you take the apply formula, difference of sine, which is gonna be number 4, right? It's gonna be number 4, okay? So I would highly recommend you to write down from the very beginning this formula, all 4 formulas. So number 4, and what we are going to get, it is going to be sine 45 degrees cosine 30 degrees minus cosine 45 degrees sine 30 degrees. All right, so we know sine cosine 45 degrees, it's square root 2 over 2, right? Okay, cosine 30 degrees, if you open unit circle, is going to be square root 3 over 2. minus cosine 45 degrees square root 2 over 2, and sine 30 degrees, it's going to be 1/2 based on unit circle. And the result is we are going to get, so I'm multiplying these two, square root 2 times square root 3, and multiply these. So we are getting square root 6 over 4, and minus second one, square root 2 times 1 is square root 2 over 4 again. Since denominator is the same, so all we have to do is subtract numerator. Square root 6 minus square root 2. And we can't do anything with numerator anymore. So and that will be your final answer. Square root 6 minus square root of 2 over 4. Okay? Next. Now we are going to do opposite to number 5 problem. And what is it going to be? Number 6, let me see. When you have sine 105 degrees. So since we don't know how much is 105 degrees, but we can break down 105, we can break down as 60 degrees and 45 degrees. What a nice solution, right? So it is going to be sum of sine. Sum of sine is formula number 3. We're going to have sine alpha cosine beta, cosine alpha sine beta. So our alpha will be 60 degrees, beta would going to be 45 degrees. And we have sine 60 degrees, cosine 45 degrees, plus cosine 60 degrees, and sine 45 degrees. Okay, so what do we have to do from here? It's all unit circle around, 60 degrees, 45 degrees. So 60 degrees, sine 60 degrees, it's square root 3 over 2. Cosine 45 is a square root 2 over 2, right? Plus cosine 60 degrees, that's a 1/2. Okay, and sine 45 degrees, that's a square root 2 over 2. All right, what do we get from here? So if we multiply the first multiplication and then second multiplication, we are going to get square root 6 over 4 plus square root 2 over 4. And we are getting common denominator is 4. The numerator will be square root 6 plus square root 2. And that will be our final answer. Let me solve one more problem and I will be done. I'm trying to apply all forms, format of problems you can have to use sum and difference of sine and cosine. Okay, number 7. It's going to be sine x minus y over sine x plus y. Okay, well, we have here and sum and difference of sine, right? Let's go back and look at our formula. So here it is, addition and subtraction. What we're gonna get? Sine alpha cosine beta plus cosine alpha sine beta, and same thing here with the plus and minus. And then what we're gonna do? Nothing else we can do. We will hit the wall at this point. Therefore, we have to go different ways, see how we can manipulate. Look at the problem number 1 and 2. Look at that. Here we have in numerator, we have sine x minus y, right? Look what we have here. Sine x minus y, or alpha minus beta, same thing. If you divide by cosine alpha sine beta, you are going to take tangent cotangent minus 1. Or you also can divide sine alpha sine beta. So this is, I'm going to go that way. I'm going to take both numerator and denominator, divide by the same sine x sine y. So I'm going to use different method here, because as we saw, applying these formulas is not going to help. So sine x minus y, it's going to be sine x minus y over sine x sine y. Okay, let me use red color. So sine x minus y, and here we have sine x sine y, and then in denominator sine x plus y. Okay, also dividing by the same sine x sine y, because whatever change you do to one part of the fraction, you have to do exactly same change to the other part of fraction. What we are going to get here, let's see. Now, only now I'm going to open formula for sine x minus y. So x minus y, it's going to be formula 4 here. And it's going to be here formula 3. So we are going to get, I hope you wrote down the formulas. So sine x cosine y, remember the sine, it's more friendly, allow sine and cosine coexist together. So sine x cosine y minus sine y cosine x, and this we divide sine x sine y. Next, sine x cosine y plus sine y cosine x. That's applying formula 3. And still divide by sine x sine y. Okay, this is going to be equal. So we are going to separate sine x cosine y over sine x sine y, and then minus sine y cosine x, again divided by sine x sine y. Same thing, I'm going to denominator sine x cosine y over sine x sine y, all right, plus sine y cosine x over sine x sine y. Okay, let's see what's happening if we can cancel. Let's take first fraction, sine x cosine y, sine x sine y. So sine x I can cancel with sine x. Second one, sine y, I can cancel with sine y. In denominator, sine x, I'm canceling with sine x. And the other term in denominator, I'm canceling sine y with sine y. And as a result, we will get So cosine y over sine y minus cosine x over sine x, and in denominator left over is cosine y over sine y, and plus cosine x over sine x. So from here we get cosine y over sine y, it's gonna get a cotangent y. Cosine x over sine x, it's gonna be cotangent x. In denominator, cosine y over sine y, we get cotangent y. Cosine x over sine x, we are going to get cotangent x. And this is what we get, cotangent y minus cotangent x, and cotangent y plus cotangent x. Okie dokie. Thanks for watching. I hope it helped. And I see you in next video. And I will pretty soon start recording calculus problems. And we'll continue also this precalculus also. I'm going to cover all formulas, the common formulas that are used in calculus. So prepare you in this precalculus, prepare you for the calculus version. Okay, see you again in next video.